do the quiz. I think it was problem number 2. The exercise 2. Now section talks about repeating experiment more than once. So that's a little extra. So in the previous sections, we had only one time that we did experiment, but now we repeat it 2 times. So you need to find the probability that on the first spin you get yellow. So in exercise number 2, we have to find probability of yellow, and this stands for times probability to get green. They're completely independent. We assume this little device with a pointer does not remember what it pointed at previously. So out of 6 total choices, I can see 1 yellow, and means times out of 6 total choices, we have 2 green ones. So some people that good at arithmetic simplified, that made me very happy, and ended up multiplying 1 and 1 in numerator, so produced 1 and 1 and 6 and 3 in denominator, so they produced 18. So it looks like the answer is 1/18, or some other people just use their calculator, which is also absolutely fine, and produced some decimal, which is in the form of 0.0555 ... So we have also such a possibility. So anyways, looks like we have nice answer in here. And I think 1/18, that's what most people had. And we can do some more problems on this page just for fun. So you would like to look at problem number 25 and 35. I think that's great that you're doing homework. So that's from section 11.6. So let us take a look at those. I think it's always a very good idea to do some problems that you found for me. So please ask questions. That makes me very happy. I'm going to do my best to help you with those. So 11.6 is a section we just considered. So I'm looking for problem 25. So in that section, I told you not to bother with the second page starting at 49. So we just look at the first page with exercises. I think it's plenty in there. So in exercise 25, we have a question that deals with a die. And that's one of our old favorites, right? A little cubes that we roll called dice. And this is asking even number or less than 5. What does that mean? Well, let's take a look at what they're talking about in terms of that little cube. So there are 6 sides on it. There are 6 possibilities from 1 through 6, right? So I can put all of them here. That's 5, and finally 6. So they want a probability that you get even or less than 5. So out of the 6 choices, total is in denominator. So total is 6. What are they talking about when they mention even? They say, oh, we already saw that even is either 2 or 4 or 6. Okay, so these 3 choices, but it's not over. We need to add to this numbers that less than 5. So what is less than 5? Well, less than 5 will be also 1 or 3. One you say, or 2 or 4. Yes, but they're already taken. So it looks like we need to choose all of them with exception for number 5, because number 5 does not fit description of being even, and it doesn't fit description of being less than 5 either. Okay, so leave the 5 alone. Please notice that we do take 6 because 6 is even, although it's not less than 5, but it is even, and that's what we need to select. And looks like this will be our answer, 5 out of 6. So you can leave this as a fraction, that's fine. So it looks like we produce fractions. And again, notice the difference with the previous section. We don't repeat experiments more than once. We just do it one time only. So next question is exercise number 35 that asks a professor or male question. So let's see what they are talking about here in this exercise. And again, it looks like they want to know the probability. So I want to write this as a professor or male. So that's what they want to find. And the story says that the department in the college has 8 male professors, 11 female professors, 14 male teaching assistants. So let me write all that down. So 8 male professors and 11 female. And also teaching assistants, 14 male teaching assistant and 7 female. 7 female. Okay. So we have this group of people that they consider, and looks like this entire group totals 25 and 15, 40 people. So there'll be fraction with denominator equal to 40. So I put all people together, right? That's total, that's my denominator. So now I need to take either professors, and that will be 8 as well as 11, or, which always means plus, male. So it looks like that's another number I have to add in here. So this will be something like 33, right? So we end up with a fraction which is 33 out of 40. So this is our probability or a fraction for these. Good question. Interesting. So I guess I'm gonna go back to the section that we are at, and we'll do more. We'll do more exercises that deal with repeating experiments and actually multiplying one probability by the other if you need to do one and means times the other. So multiplication rule is at work, in other words. So how about exercise 23 that consists of experiment that deal with doing 2 different things, one and then the other. And 23 says you toss the coin and then you also roll a die. How about that? Okay, so it looks like these two are very familiar procedures. So in exercise 23 here. We need to find the probability to get a head and number greater than 4. Okay, so probability of head and so I get times probability that we get greater than 4. Okay. So to get a head, when I roll a die, actually flip a coin, we know that out of total of 2 possibilities, there is only one head, right? And one tail. So if you flip your coin, then it's 50% that you get a head, 50% that you get a tail, of course, if it's a fair coin. Now, when you roll a die, so we already know there are 6 possibilities for so-called outcomes. So out of these 6, I need to be greater than 4. Well, it looks like there are 2 selections, 5 or 6, greater. 4 is not working because 4 is not greater, 4 is equal. So since it's end, I'm gonna multiply, and when I multiply fractions, I can reduce these by 2 and get a little answer. So it'll be something like 1 out of 6. And that's it. So we just multiply again and again. So we take probabilities and times 1 by the other. What I just did, I flipped the page and I want to look at, well, next group of problems here. So we'll run all the way up to, I guess, end of next page. So let me start it today. This section actually has very interesting exercises, I think. So besides just multiplying, well, you need to be a little bit more careful. Let me try another exercise, like problem number 31, that deals with various party affiliation. But we should be careful when we read this, because we're dealing with 5 Democrats, 6 Republicans, 4 independents. So 5, 6, and 4 here. And the question is, find probability that we get 2 Democrats. So 2 Democrats. Well, it turns out that there are, I guess, 2 ways to do this exercise. And well, let me show you the old way and then the new way. And then you will decide which way you like to do it. To me, it doesn't matter. You can do any way you like as long as you do it right. But I'm here just to show you how we can select from group of 15 people. So the total number of selections will be combinations from 15 to choose 2. Why combinations? Well, because they don't tell you how you arrange those 2 Democrats. You're not saying we first put the taller one and then we put the shorter one. First we assign one position, you're the boss, and then you're the helper. No, we just select 2 people. We assume they're on totally equal level, so we don't care about order. That's why it's combination. So order is not important. Remember, if we care about order, permutations. No ordering, combinations. So I have 2 choices out of group of 15 people, just like we did before. And now the numerator of this fraction, I also gonna have combinations because again, we don't care about order. But now I choose 2 people out of only group of Democratic senators, so 2 out of 5. We did this back in the previous sections, right? So one can say, Alex, why this is here? Well, let me get the answer first, and then we'll do it the other way. So I'll show you why. So we need to go to functions, remember? Combinations is here. And then we go back to numbers and put 15, comma 2. Oh, sorry, numerator is 5, 5, comma 2. And then divide by, again, combinations, back to functions, combinations. And then 15, comma 2 is on the denominator. Well, it looks like it's like 9%, whatever it is, I just write it down. 0.0955, actually 9523. 23, dot, dot, dot. So we have probability. Well, I'm going to say the way the process actually goes is you select out of group of 15 senators, first senator who is Democrat. So we can see that probability to get a Democratic senator will be out of 15, choose any of these 5, right? So we have total 5 Democrats, 6 Republican and 4 independent. So I can take any of these 5 people, and 15 is my total, so 5 out of 15. And then I have to choose another senator. But please notice, when I selected first Democrat, I cannot select exactly the same person, right? I need to select a different person. If somebody tells you, bring me 2 Democratic senators, and you bring 1 person, and they say, so where's the second? I say, you know what, Alex, I selected that senator once, and then I decided to select the same senator again. They say, no, no, no. You don't bring me 1, you bring me 2, which means when you already selected 1 senator, you no longer deal with 15, but you left with 14. You see, you left with 14 people. You don't have 15. And then you already selected 1 Democrat. So you left with 4 of them. So it'll be 4 to choose from the second senator. So it will be probability to select another Democrat, people say, given that you already chosen 1 Democrat. That's kind of interesting, right? So when you select the second senator, everything changes. So let me put this in a calculator and see what we're going to get this way. So I'm going to put those 2 fractions. Please notice I want to use parentheses around fractions. 5/15, one is Alice, that's 1/3. Yeah, it is. You could let calculator do this. And then you multiply it by 4 out of 14. And look what you get. Exactly the same answer, right? And it's not surprising because we do the same problem and the answer is, of course, same, no matter how you solve it. So my goal today is to show you this so-called conditional probability, which means that your experiment changes after you selected 1 person. You don't want to select the same person again, so you keep that person aside and your sample gets 1 lower, and that's the idea. So the way to go is just do more problems and get used to this procedure. I know it is a little bit unusual. So how about one more here, like exercise number 35. Let me clear this a little bit. Exercise 35. It says no independence. No independence. What's the probability that you're gonna select that? Again, I can do it two ways just for fun. So I'm gonna use this conditional probability first. So we start to get used to it. So it looks like we no longer care about independence, but we still have 5 Democrats to start and 6 Republicans and 4 independents. So the total is 15 people. So if I want to get no independent on my first selection, then from 15 senators, I choose any of these 11, right? So I don't touch 4 independents. I just want to select one here. So I have 11 to choose from. And again, I need to select no independent, but we given that I already selected one from that no independent group. So we have this conditional probability, and it happens that we no longer have 15 people to deal with, just 14, and no longer 11, but one less, 10. So I multiply this by 10/14. So please notice that it's very, very similar to the previous exercise. The fractions start to lower by 1 and their numerators and their denominators. So it's kind of standard, turns out. So what you do is you just put in the parentheses this 11/15. So that's the first one. And then another parentheses 10/14. So please notice when you put this all in the calculator, you don't need to simplify anything by hand. Unless you really like it and enjoy it, then yes, of course you can do this. But calculator will take care of it for you. Don't worry. So it's 52380 dot dot. So about 52%. Conditional probabilities here. So if someone will ask me, Alex, how would you do it using the old methods? Well, we already know our denominator for the old method. Remember when you select out of 15 people, 2, so that'd be combinations to choose 2 out of 15. And what would be numerator? Well, we're still selecting 2, but it's out of 11. So you can see that the answer should be the same. If you feel like it, you can put it in your calculator. But the point of story that you can use either method to do this problem. One is, Alex, why are you using 2 methods? Why did you do the same exercise 2 ways? Well, the problem is called nice. I don't want to use word easy, but nice. If you can do it one way or the other way or the third way, so any way you do it, you produce the answer. Problems that are harder, you need to find that only way that brings you to the answer. So you go in one direction, dead end. You go in the other direction, dead end, cannot do it. So then you find the solution by finding some other method. And that's the reason why I show you various methods in the case if you ever encounter challenging exercise. Please don't worry, I don't plan to give you on the tests any challenging exercises. I think it'd be okay if you just do the standard ones. So let me do one more exercise here. Maybe I'm not going to give you a quiz today. I know this is something new, this conditional probability, so it may be making people feel a little bit uncomfortable. So let me, well, just make sure you get used to it. So I'm not going to give you a quiz. I'll just do one more problem for you instead. I think that'd be fair, right? So let me do the quiz, in other words. So let me try something that is related to this table here, the car accidents in Florida. So how about that? So it says little table is here. So driver survived or driver died. So there are two possibilities, either survive or die. And they have total, and that's a big total, over than 400,000 accidents. So notice that most of drivers survive, which is great. And what they do is they looking at the seat belt. So it turns out that there are some drivers wore seat belt and some did not. So it looks like most people wearing seat belt, but well, some wouldn't. And here's the grand total, which is 577 some thousand accidents considered. So let me take a look at problem 61 related to this summary that says, find probability of surviving a car accident given that driver wore seat belt. So how do I do this? Well, I can say probability to survive given seat belt. Given means we are here. So what's important to realize is that your sample is no longer 577,000. It's given to us that we are dealing only with 412, 877, 878 actually, because we are dealing only with seatbelt wearing people. So when you have this conditional probability, you no longer are looking at entire sample. What's given, that's what you're looking at, just 400 some thousand. And then, well, we're interested in the group that survived, which is right there, 412 something thousand. So I just write it down, 412 and 368. So I have produced a fraction as usual, because probability is always the fraction. And this thing definitely needs to be put in a calculator, because something like that definitely is not the answer. They're both even numbers. And I don't think you want to simplify those. It's a little bit too much, right? So 412, 368, I divide by 412, 878. So here's the answer. It's like 99 some percent. So what does it tell you? Well, looks like if you're wearing seatbelt, it's 99% that you're gonna survive, right? So wear a seatbelt. If you like to drive real fast and pass all these people like maniac, well, wear a seatbelt if you want to survive. It's a good idea, right? And let's do number 62. So that's 61. So 62. That says, how about if you find the probability of not surviving given driver did not wear seatbelt? In other words, not surviving or dying given not wear seatbelt. No seatbelt. Well, looks like that's another interesting thing to find out. So we no longer care about seatbelt wearing people. We're given that the person does not wear seatbelt. So that's a group right here. please notice that it has nothing to do with the previous calculation. So when you have this conditional probability, you always have only a part of your sample. So no seatbelt means that the person is among this 164,000. So what's the number of those drivers that did not survive, that actually die in that accident? Well, looks like it's 1601, right? Because survived people is not what we're interested right now. We asked to find those that did not survive. So it's 1601. And again, it's a calculator time. So let us get this calculated. It's 1601 divided by 164,128. So the chance to not survive, when you say, well, it's still pretty small. Yeah, it's close to 1%. So 0.00975 and so forth. So close to 1%. Is it likely? Well, not very that someone dies because not wearing a seatbelt, but well, it's still a chance of that to happen. So that's what they wanted to calculate, and we did it. So there it is. So when you say the seatbelt really help, I don't know. Well, that's for you to decide. If chances are so low, then probably it doesn't, right? Anyways. So it looks like I look at the conditional probability in this section. So the advice is that you try to redo these problems that I done today. I can see what else is in this section in the meantime. Looks like there is more, but I think we don't need to bother with every single exercise here. My plan is not to look at this last page. So you can just look at page that I have here for you. So if someone wants to make a copy, let me clear the mess. And sometimes people like to do the print screen of this part of the page, right? And then you can do print screen of the lower part of the page. Maybe it's this picture. Okay. So I guess as promised, I will let you go with no quiz. I remember the promise. So we talked about this conditional probability. I think it's good to know, because when you repeat your experiment again and again, sometimes nothing changes, but sometimes your sample, if it's limited, changes, like we saw in this Democrats Republican story. So we need to adjust to get the less people considered. So that's all I wanted to talk about today, conditional probability. It may seem to be pretty obvious when I'm talking about it, but advice is redo problems that I did and try some of those, because it is not obvious stuff. So one needs not to over relax on this, because this topic of probability is very interesting. And that'd be the last topic that we're going to talk about related to this. So let me stop to record.